In this video, we're going to introduce nice scene background applied by cube map texture to create a skybox, which is a wrapper around the entire world scene, showing what the world looks like beyond our actual geometry. So this is our presentation. Cube map textures are used for making skyboxes and faking reflections on the surfaces of objects. So cube map is comprised of 6 individual texture images, which will be applied in 6 different directions accordingly, with the left, right, front, back, top and base of our entire environment. So the cube map requires 3 texture coordinates, S and T, just the same way they're used with regular textures for sampling, and also an R coordinate which identifies a specific image. So it's basically 6 unique images that we specify with our R coordinate. And here cube mapping allows us to visualize the world, how it looks like beyond the actual geometry in the far background. But also reflection cube map creates an appearance of a reflective surface of a rendered object using the same background texture as in a distant environment surrounding. The approach to uploading cube map textures is similar to regular textures. First of all, we need to create and bind a texture buffer. Then we use GL texture image 2D, the call that we already used to upload our textures. But this time the first parameter is specifying the texture cube map coordinate, which can be positive x, negative x, and the same for other axes. Just as with regular textures, we can specify texture parameters or texture preferences with the cube map texture. It's the same GL texture parameter call, but this time we're using the type specifying texture cube map. And we can continue using magnification and minification filters, just like with other textures. But regarding the wrapping of the image, what we normally use is just this wrap S, T, and R, and specify clamping to the edge. Skybox is an object to visualize distant environment surrounding. It is actually not a sphere, but a simple box, a cube shape, with the cube texture images applied to every side on the left, right, front, top. And the trick is that, for example, if we have a world space, right, so we have the world coordinates, and we have positioned some objects in the world space to make them visible right here. So these are the world coordinates. And we position the camera somewhere here, looking this way at our objects. Right, so this is the direction of the camera. And so the trick is that the skybox, like a giant box, surrounds the camera in such way that the camera is always at the center of the skybox. All right, so this is the skybox. I'll try my best to draw the straight lines and basically just keep an eye on the camera. Right, so this is our observer looking down this way, and so the camera is directly in the center of the box. Okay, so this is our box like this, and it's in the center, but this box object never moves anywhere. For example, like if the camera moves forward a little bit, like by this much, and now the observer is located here, and we continue looking down this way, the skybox remains unmoved. Therefore, the surrounding background appears to be the same to the observer. Basically, the skybox still remains in the center, so the camera still remains in the center of the skybox. So therefore, the new position of the skybox is like this. So it just moves just like the camera moves, so that the camera actually stays where it was like this. So relative to the camera, the skybox never moves. At the same time, the skybox does rotate with the rest of the world. So the observer can change the angle of the camera and start looking this way. So of course the box will rotate. And when I talk about movements and rotations in the context of the skybox, of course everything is relative to the position of the camera. In the end, when each display frame is rendered, the camera never moves. It's just the world, the objects and everything rotates and moves around it. To render Skybox, we're going to use a special fragment shader specifically for the Skybox, which is using the sample cube uniform variable for the texture sampler to sample the texels to display the Skybox environment. So this is an example of the fragment shader for the Skybox. So this is the uniform sampler cube. We call it cube map. The shader also gets the UV coordinates input. And then we call built-in function named texture to use our sampler and specify the texture coordinates to retrieve the fragment color for the Skybox. And here is another very cool trick. Notice that we don't take any texture UV coordinates input in our vertex shader, like vertex attributes from the CPU memory in order to feed the texture coordinates to the fragment shader. Instead, we create the texture coordinates on the spot in this vertex shader. Because the camera is always in the center of the cube, we take each vertex position and normalize it, which, by the way, brings the process of sampling the texture colors closer to sampling a sphere, but, well, just a little bit closer. So this is our texture coordinates that we pass to the fragment shader as input. Okay. This is the pair of shaders that we use to render the Skybox.